So let's talk about a difference of squares. A difference of squares is another factoring technique that you're going to need to get really good at identifying in Algebra 1 and Algebra 2, and even beyond when you take pre-calculus or calculus. So let's take a look at an example. Let's start with a very basic example of the difference of squares. Now, what I notice here is there are really three bullet points that are going to qualify something as a difference of squares. The first thing is that you have two terms. The second bullet point is that there's a minus sign separating the two terms. And the third one is the most critical and most important. And the way I explain that is this. If you can draw two blanks and multiply something by itself, so you need the exact same piece twice, multiply something by itself to get each piece, then it truly is a difference of squares. Now let me explain that a little bit more in detail looking at this example right here. So this has potential to be a difference of squares. And I'll go down the checklist. Are there two terms? Yes. Is there a negative or a minus sign separating the two terms? There is. And then here's the most important part. What I'll do is draw two blanks to the side and ask myself, can I multiply something? It has to be the same exact thing by itself to get x squared. And yeah, sure, you can multiply x. X times x by itself is going to produce x squared. And then you'll ask the same question here. Can you multiply something by itself? It has to be the same exact thing and get 4. Well, sure. That's 2. And then I'll typically write this plus minus off to the side to help me figure out the factors. So yeah, this is indeed a difference of squares. What it'll factor into is both of these pieces. It's going to be x plus 2 and x minus 2. And the reason being is if I foiled this back out, because sometimes students will be confused on why there's one that's positive and why there's negative. Well, it's because you're missing just an x term, something that's linear. So if I did FOIL right here and did first, outer, inner, and last, what would happen when I go to combine these like terms right here is they would actually cancel each other out, leaving me with just x squared minus 4. Now let's try another example. Say that you have 100y squared minus, let's go with minus 9x squared. Now, again, I'm going to try the 3 series test to see if this actually is a difference of squares. Are there two terms? Yes. Is there a minus sign separating the two terms? For sure. And can I build my two pieces? So I'm going to come back over here and try the same exact thing. Is there something I can multiply by itself? It has to be the same exact thing to produce 100y squared. Well, sure. The first piece is going to be 10. And then the second little part on there is going to actually be 10y. 10y squared, or 10y times 10y, is going to produce 100y squared. And then let me ask the same thing about 9x squared. What could I multiply by itself? That's going to be 3x. So was this a difference of squares? Yeah, it met all 3 criteria. And what it's going to factor into writing that plus minus sign is going to be 10y plus 3x, using it in the same order that I wrote it in the blanks, and 10y minus 3x. Let's look at another example here. So going back to the 3-step process to figure out if something truly is a difference of squares. First thing, two terms. The second step, there's a minus sign separating those two terms. And then the last step is, can you multiply something by itself to build those two pieces? And if you can answer that, if you can answer yes to all 3 of these, and specifically for both of those pieces, it is a difference of squares. Now, here's the trick on this one. Before you do anything, no matter what type of factoring you're doing, whether it's a trinomial, difference of squares, factor by grouping with a polynomial, you always want to check for a greatest common factor first. Now, when I look at this example, there is a GCF. The GCF here is going to be 2. So currently, it's not a difference of squares because, yes, I do have 2 terms. Yes, there's a minus sign. But can I multiply something by itself to get 2x squared or 18? The answer is no. But watch what happens when I factor out a 2, that GCF. I'm actually going to divide each of those terms right here by 2. So I'm going to be left with x squared, and then negative 18 divided by 2 is going to give me negative 9. Now, as I look inside of here, is this a difference of squares? Did it actually reveal something? Well, let's see. Are there two terms? Yes. Is there a minus sign? And can I multiply something by itself to get x squared and 9? Yeah, the answer is going to be x and 3. So was this truly a difference of squares? Absolutely. I'm going to have one factor as x plus 3 and the other is x minus 3. But just because I pulled out a GCF does not mean that I'm going to get rid of it. It still needs to remain in my final answer. So if you ever factor something out, continue writing it all the way down. The point of showing you an example like this is that sometimes a difference of squares is going to be embedded within something. What you'll have to do is pull out a GCF to actually reveal the difference of squares. Now, another example would look something like this. Let's say we have x to the 5th minus x. Now, again, first and foremost, I always want to check for a greatest common factor. In this example, the GCF is just going to be a singular x. Now, when I divide both of these terms by x to the 5th x to the 5th divided by x is going to give me x to the 4th, and negative x divided by x is going to give me negative 1. Sometimes that part will trip students up, but if you need to go to the side and write both of those pieces being divided by your GCF, that's where I'm getting x to the 4th minus 1. Now, as I take a look inside here, would this qualify as a difference of squares? First of all, does it have two terms? Yes. Is there a minus sign separating them? Yes. And could I build those two pieces? Is there something I can multiply by itself to get x to the 4th and 1? The answer is yes. I'm going to use x squared for my first term and 1 is my second term. So I need to continue to write that x, the GCF that I pulled out at the start. But what those two pieces are going to give me is x squared plus 1, it's one term, and then x squared minus 1. Now, most students here will not receive full credit because what you have to realize is that there's still a difference of squares embedded within this. If you take a look at that part right there, does that meet the criteria of having two terms, a minus sign, and something you could break down to multiply by itself to get both of those pieces? For sure. I could multiply x by itself and 1 by itself. And again, that's going to break up into plus minus. The reason why that first term, that x squared plus 1, is not a difference of squares is because it's using an addition sign. Remember, one of the big criteria is that you have to have a subtraction sign. So to fully factor this, I'm going to leave the first two pieces alone. They are fully factored. But that very last piece in pink is going to break down into x plus 1 and x minus 1. Now I have fully simplified. Definitely be on the lookout for a difference of squares that may be embedded within something. Sometimes you just have to pull out a greatest common factor first, and it will reveal something that you can continue to factor. Having that eye for a difference of squares and being able to break it down quickly by building those two pieces and going through the 3-step process is going to be crucial in your math journey.